In today's Python Pandas video, we're going to be taking a look at percentage change, which will give you the decimal difference between either rows or columns within your data frame. We'll also cover a lot of different concepts like periods, as well as using this with a group by. And this is going to be very similar to diff, also known as difference, except this will give you the decimal difference. Not necessarily a percentage difference, but I'll show you how to convert that into percentage in literally just one line of code. But with that out of the way, let's grab a Google Colab notebook or whatever Python notebook you want to use, and let's start coding. All right, let's get started. We're going to import in pandas as well as NumPy. So import pandas as PD, import NumPy as NP. This may take a second to run, but click this over here, and then we can get started. So what we're going to do is we're going to create a few different data frames throughout this video. We're going to start off with one based around YouTube views. So we're going to say df YouTube equals pd.dataframe. And then what we're going to do is just pass in a dictionary called YouTube views, and then pass in a few different values. I'm literally just going to copy over what I've already used. And again, feel free to copy from the source code as well. This video isn't specifically focused on building out data frames. It's more focused on percentage change. All right, so we have YouTube over here. What I do want to show you really quick is what this data frame looks like. So we'll put that over here, df YouTube, and you'll see we have that going. So I have YouTube views 125, 800, 335, 400, and 1500. So we are good to go. And let's start off with example one. Now, I'm going to split up example one into two different things. So we'll say example one, which is part A, which is going to be our default periods. So default periods like that. And by default, we're only going to look at one row at a time. So all we're going to do over here is call this df YouTube and call this views change. So views change like this, views change. And we're going to say this is equal to df YouTube. We'll have a YouTube views over here. So YouTube views, and then dot percentage change. So PCT underscore change like that. And what we'll do is take a look at this now. So we'll just go over here, look at df YouTube, and you can see the percentage change across the board. Well, not necessarily. This is actually just the decimal difference between them. You can see over here we have 5.4, 0.58, 0.19, 2.75. This is a negative 0.4. And what you can see over here is this is actually not the percentage change. Although Pandas calls it percentage change, it's actually the decimal change difference. You can see we have 5.4, negative 0.58, 0.19, and 2.75. And obviously going from 400 to 1500 is not 2.75, that'd be 275%. So what I will show you really quick is how to convert this. Now for the full video and transparency side of things, I don't want to multiply this by 100 every time. So I am just going to use percentage change like this. But let me show you how I can multiply this out really fast if you just want to see the true percentage change. So all you got to do is go over df YouTube, and then we're going to put over here views change, and we're going to say 100. And literally all you have to do is go df YouTube, then grab our views change, then times it by 100. I know I have a typo over here, so we're just going to say this is equal over there. Now we'll get rid of that. And now if you want to have the true percentage rather than the decimal, you see we have that. Now, one thing to also call out, we'll always have our first row as null values. I will show you how to fix that a little bit later on in this lesson. But one thing to note on this is since we don't have data above, it's just going to be null. But we do have data below, so that way we can figure out the views change over here, or the percentage change over here. I should say decimal change or the percentage change. But yeah, I completely understand why they have it as the decimal change instead of percentage change. But it is kind of misleading in my own personal opinion based around that. So what we're going to do now is go through our next example, which looks at the periods parameter. So this is pretty easy. We'll go over here to example 2, and what periods allows us to do is to essentially look over multiple rows instead. So what we're going to say is df YouTube, and actually what we can do is like essentially copy what we had up over here. We're going to make a minor change really quick. So we have views change equals df YouTube views percentage change, And all we're going to pass in over here is periods equal to. So periods equal to, like that. Again, identify the column that we want to look at. So views change, and then, identify the column you want to look at, which is YouTube views right over here. We'll find the percentage change, and we're going to look at periods too. I'm just going to say this is going to be called 2 periods. So 2 periods like that. So we have that, and what I'll do is take a look at it now, and you'll see now we have 2 null values. Well, the reason why we have 2 null values is when we go to 125, right, we have nothing before it. It starts at index 0. That makes sense. Well, we go to index 1 now, and we try to look at the difference 2 above. So 1, and well, 2 is missing. So now we have 2 null values. So depending on how you set your periods, you could have up to n amount of null values when you first start your data frame. If you continue this out, like 3 would have 3 null values, 4 would have 4, but it looks at 2 above, right? So we see we have the 1.68 over here. Well, this looks at 335 compared to 125. You could do the math on it for the percentage change, right? New minus old divided by old. That will give you our percentage change that we have right over here. Well, this is decimal, so just multiply it by 100. So there is that side of things. That's how you use periods. Pretty easy. Another thing to mention is some people just want to see the absolute difference, which is just going to be the positive value on that. So that's going to be our third example. So 3 is apps difference. Apps should say percentage because we're not looking at differences anymore. And again, very, very simple on this side of things. So what I'm going to do is just grab our initial code over here because we're not going to skip periods now. And we're going to go over here, views change. We'll call this abs over here. And we'll go, actually for the tutorial, I'm going to just keep it 1-to-1, what I have on the article, which is views absolute difference. So again, default YouTube views, percentage change, and then just add on ABS at the end. This will make all our values positive. And yeah, so if I just go over here to DF YouTube, you'll see all these are positive values now. So we have 5.4, 5.4, this is 0.518, or this is 0.581, then these are the same as well, 0.19 and 2.75. All right, so now what I want to show you is how you can use diff with multiple columns and rows. So we'll say example 4, diff multiple col and rows. And what we're going to do is actually create a new data frame for this. I'm just going to copy it over to save you guys a little bit of time. But we're going to look at card sales. Like, let's say this is the volume of card sales for Donald Bradman and Nolan Ryan. When I talk about cards, like things like this, like trading cards, right? So what we're going to do is look at that. So Donald Bradman, cricketer, Nolan Ryan, and baseball pitcher, who I was named after. And we'll have both of those over here. And just to show you what this looks like. Donald Bradman, Nolan Ryan. Now, there's 2 approaches that we could do. We could either create brand new columns, or we could just see the differences or the percentage difference all at once. So I'll take you through both of those. All you have to do is we want to look at all the differences on here. Is just go over here, .pct change. Now, I don't always recommend this approach. Personally, I like adding in new columns instead, because then you can't see your initial data, but you can see that this gives you the percentage difference for Donald Bradman and Nolan Ryan when you look over there. But again, what I recommend is you build out brand new columns. So let's do that. So we'll say monthly card sales. And since we're doing 2 columns, we're going to do double brackets. We'll call this Donald Bradman. So Don Bradman diff. And then what we'll have next is Nolan Ryan diff. So Nolan Ryan diff. And then all we're going to do on this side of things is equal monthly card sales, and then again, just add in your percentage change. So PCT, and then change, which we literally just have right over here. Same exact code, right? Percentage change. Oops. Change that. And now, if we go over here, we have our new columns. One for the percentage change for Donald Bradman, one for Nolan Ryan. Again, pretty basic example on this side of things, right? Bradman, 28 to 46, right? And you can see 46 minus 28, 18 divided by 28, and then 33 minus 46, right? That's why we have the negative value. And then Nolan Ryan, 702 minus 511, and then 611 minus 702 divided by 702, right? So we get the negative value over here. All right, now let's just look directly at columns. So everything I've showed you, we've been looking at the difference between rows right? This just added in multiple columns. Now let's take a look at just finding the difference across columns. So we're going to say example 5 difference, so percentage diff across columns. And I know it should be decimal diff, but we're just going to keep going with the percentage diff in this video. So what I'm going to do is pass in the data that we're using in this video too. So DF merchants, so this is quarterly sales, let's say for Q1, Q2, and Q3 across 2023, 2024, and 2025. I mentioned it also in the diff video. I don't know why I didn't put a Q4 when I started prepping this video, but a small mistake I made. But I want to keep these essentially the same. As you can see, the slight differences between them. But regardless, we have that over here. We're just going to set an index. So DF merchants, we're going to say .index.name. We'll say this is equal to year. And then I'll just show you what DF merchants look like. Again, pretty basic. Q1, Q2, Q3, and 2023 through 2024. So now what we can do is just quickly look at our change. So what we can do on here is say DF merchants. And what we're going to add in over here is %% change. And one difference, so since we're looking at columns only this time, we're going to use axis equals 1. That way, instead of looking at over rows, we're going to take the over columns. So it would be like 211 minus 182 divided by 182, right? Again, we're finding percentage change. And you can see over here, all Q1 null values because we didn't have anything before Q1. Q1 starts in January anyways. Then we have Q2, and then we have Q3 across the board. And I know someone would say, well, technically, right, if you 2025, Q1 would have 2024 beforehand, but I just made it looking like this, like if you're looking at a specific year across the board, right? So we start at Q1, then Q2, then Q3. That's just how I built this as a fairly basic example, right? All right, so now let's take a look at a time series example. So we'll say example 6 is more time series on like a daily basis. So example 6 time series daily. And what we're going to do is look at temperatures in Zermatt. So we're going to go over here, dates. We're creating a date range. We're going to start on 4/19/2025. We're doing a period of 7 days. So period 7 frequency is days over here. And then what we're going to have is these temperatures on that side of things. I'll just copy and paste those because it doesn't matter too much, right? We have that. And then we'll just create a very quick data frame. So df temps equals pd.dataframe. We'll pass in our date. So date, and then pass in dates. And then we'll grab in our temperature. So temperature and pass in temps. So temps like that. And we should be good to go. Show you what this looks like really fast for df temps. And there we go, right? The date and then temperatures. Now we want to set this as our index because we're building a time series analysis. So what we're going to do on here is say df temps dot set index date in place equals true. Great. And then what we'll do next, I don't know why I accidentally loaded it above, but now we have it over here, is sort our index. So it should be ascending by default. So sort index, and then we'll say in place equals true. And again, it already is in order, but always do that with your time series data. It's just important there. All right, now we're going to look at the temp change. So df temps, what we're going to say over here is temp change equals df temps temperature and then dot percentage change. That's, sorry, I actually have a small typo over here. There we go. And then let's look at what this looks like. You can see the percentage change across the board, right? Again, a little bit different on here. We don't have our first row. We'll cover that a little bit later. And you can see 32 minus 30 over 30, right? 0.06, negative 0.03, 0.2, 0.02, negative 0.05, and negative 0.02. All right, so we have that for df temps. Now let's look at example 7. So example 7 is going to address dealing with null values before you look at the diff. So what happens if you don't specifically, you're gonna have more null values when you run percentage change. So let's fix that. So what I'll do over here is example 7, address null values prior to percentage change. All right. So this is just based off of some train data, right? Like assuming a train leaves every 15 minutes, and these are the passengers on the train. np.nan means null values. It does not exist. We have 2 of those over here, right? So what we'll do on that side of things, we'll just create our nan df. So nan df equals pd.dataframe, pass in our data. All right. And what I want to do is I'm going to go and create 2 different rows or 2 different columns. The first one is going to be nan df. We'll just call this over here diff nulls. Right. We're going to say this is equal to nan df, and then should be nan df our passengers. So passengers. Then we're going to fill our NA, and there's a lot of different ways that we could fill our null values. I'm just going to use a fill NA for a static. We'll say we'll fill this with 100, and then do our percentage change like that. All right, so we have that over here. Okay, and then I'm going to go over one that does not have our null values addressed. So we're just going to call this as diff over here. And what we're going to do is equal to nan df. Well, it's going to be essentially the same as above, but we have to pass in 1 parameter. So I'm going to remove this fill NA because we're not addressing those. And then we're going to put in our fill method. So we're going to say fill method equals none. Equals none. And yeah, we'll have both of those over here. And let's take a look at what our null data frame looks like now. So what you'll see is one null value has a lot of impact in your data frame. So over here, these were all addressed, right? You can imagine this null value is 100 before this diff nulls was calculated, right? So this takes a look at 100 and 130, and this is pretty basic to find the percentage difference on them, or in this case, decimal difference. 130 minus 100 is 30 divided by 100, 0.3, right? Times 100, 30%. But since we have that over here is 100, and we don't address that, right? This becomes a null value because this just doesn't exist, right? So not only does it impact this row, but also impacts the row below it when you have a null value, right? So there's that side of things. Also, what's kind of cool is when you have 100 over here, like what we just put in, you can also find the percent change from above as well, which that gets filled in over here, negative 0.2. Again, we're taking 125 and 100, so 100 minus 125, right? And then divide that by 100, right? That's why you get negative 0.2. So it just shows you the difference, right? If you want to fill in your NAs and just run the calculation without actually addressing the null values in your data frame, you could do that. Personally, I would prefer that you fill in your NAs in your data frame and then jump into finding the percentage difference. But that's an option for you if that matters. The other way that we're going to look at null values right now is looking at how to fill in the first value. So fill in first value. And what I will say is check out the video I already have on the channel on filling out null values because it's much more comprehensive than what I'm going to cover here. I'm just going to go quickly through 3 different approaches on this. So what we're going to start off with is df temps, and we're going to do a backfill. So we're going to say filled backfill. So backfill. And what a backfill will essentially do is grab the next row and fill it with the previous row, right? So for example, let's say this 120 was null, right? It would take the 125 value and put that over here. So you'll see that at the very end when we finish this, but we'll say df temps temp change, and we'll call this over here, let's say bfill, right? Then we'll look at our next approach, and I'm just going to copy this 3 times because a lot of this is going to be the same. We're going to say filled 0, and you're just going to go over here and say fill NA and just pass in a 0 value. Again, there's a lot of approaches that you could use. And lastly, we're going to do a mean. So we're going to call this filled mean, but we're going to actually calculate the mean, the line above. And what we're going to do over here is go over here, say mean change equals df temps temp change and dot mean, like that, right? And let me run all these over here. I'm actually going to pass this mean change in over here and there and just put fill NA, because we're just going to fill the NA with the mean values. So we'll just go through all these. And then if we want to look at df temps, but also thinking, and I know it's late in the video, I might change these up a little bit, verbiage in the article, just to make it a little bit cleaner. But that's just something I'm thinking. But regardless, we have temperature, temp change, filled bfill, filled 0, filled mean across the board, right? So what we care about is these first values, right? Bfill, I showed you this value would be in over here. Filled 0, we just filled it with 0. Again, you can put whatever value you want. Filled mean is found the mean across over here and just populated it right over there. So a lot of cool different approaches that you could take with it. Lastly, let's look at a group by example. So we'll say example 9, which is group by, and let's jump into that. What we're going to do is I'm going to pass in our data again. Remember, check out the article because this will save you some time. But anyways, what we're looking at is different races, right? 5K, 10K, half, marathon, etc. Right? And we're going to just turn this into a data frame. So just turn that over here, see if you got some time. Also, what we're going to do is sort our values. So we're going to sort our values by the event and the date. And lastly, we'll reset our index over here. So just run both of those really quick for you guys. And what we'll do now is look at our time change between events. So we'll say df running time change, right? And we're going to say this equal df running group by. We'll pass in events, pass in time, and then just look at percent change. So pre-CT change like that. And the reason why I want to group by on this one is you really don't want to compare times between events. Like, let's say a 5K and 10K, right? 10K is double the distance of a 5K. Same with marathon and half, right? Marathon's double the distance, so it's not really fair to compare the time across those. Some of you guys might say like, oh, well, shouldn't your half, you take that times 2, shouldn't that be close to marathon? But in running, it's way different, right? A half is easier than a marathon. A 5K is way easier than a 10K. They don't just line up like that where you can take your 5K time times 2. So realistically, in this case, you want to just compare 5K times to each other, 10K times to each other. That's what we're using with this group by. And this will get us the percentage change or decimal change across the board. And you can see how we've calculated that. And you want to see negatives on here because that means you're getting faster. You want to lower time for each of these events. And you'll see over here, this runner is getting lower times for this group of runners. But yeah, that was this video. Again, just a few concepts to reiterate for you guys, just as a recap. It says percentage change. It's going to give you the decimal change. So multiply by 100 if you want. By default, right, we're looking over rows. So we're taking this row and doing the percentage change from above, right? You also have the option to change the periods where you can change it up to how many times you want. In this case, I just did it by 2. Absolute will just give you the positive. You can also do multiple rows and columns at the same time, right? I showed you how to do that. Remember double brackets. I showed you how you could do columns, set specifically axis equal to 1. I showed you a time series example over here. And then what we also make sure it's time series, super important to sort because you always want these in order. Null values, so you could address those before percentage change. And if not, make sure you put fill method equals none. And then I showed you a few different approaches to fill in the first value. You could use a bfill, fill NA. You could also use something like a statistic like a mean. And lastly, you can also utilize a group by with this. Man, we covered a ton in this video. But yeah, that is it. Again, all the code is down below in the description. Hope you guys enjoyed this video on percentage change. And if you found it valuable, make sure to subscribe to the channel. Down below in the description, you'll find links over to our Discord server, the website with the code from this video and other Pandas videos. If you want to continue the Pandas playlist, click over here.